Hi, this is Barry Hensley bringing you another episode of The Foundation Guy. And in today's episode, we're going to talk about soil conditioning. And the guest that I've got with me today is a former runway model and employee at EarthLok, Aaron Middleton. Aaron, you want to introduce yourself? Tell us a little bit about yourself.
My name is Aaron Middleton. I am a sales representative for EarthLok Soil Stabilization. Apparently, I used to be a runway model. It's a little story before the podcast started. But yeah, here to do this. Excited.
Well, we're glad you could join us. I appreciate you taking time out of your day to help us out. We want people to know as much as we can, as much information as we can give them about foundations and soil conditioning and engineering and everything that goes into making a good foundation.
Yes, sir.
And you guys are in the business of doing some kind of soil conditioning. And I guess the first thing I'd like for the audience to know is what do we mean by the term soil conditioning? What does that mean when I say that?
So soil conditioning is where a geotechnical engineer will come in. They'll test that clay and they'll say, hey, this has a 5.5 inch PVR. PVR is potential vertical rise. That is the amount of movement that you can allow over a 10-foot span under your foundation if the soil's not conditioned. What we do is we'll come in, we inject our chemical into the ground. We're not wanting to remove or add anything extra to the ground. We just want to coat that clay with an electrostatic charge that is no longer going to allow water into it. So we're not actually changing the clay any. We just want to condition it to where it says, hey, I'm full of water. I don't need any more.
So soil conditioning is a way to, could I use the word stabilizing, just equal to conditioning? We're stabilizing the soil?
Yes, sir.
Because when you mention the potential vertical rise, so the Geotech report might say that the potential vertical rise is 5.5 inches. Mm-hmm. That's too much. A foundation can't withstand that. A house would fall apart.
Yes, sir.
So what you're doing essentially is stabilizing the soil by doing this conditioning so that it doesn't move that much. Is that the result of it?
Yes, sir. So what we want to take your PVR down to less than 1% over 10 foot. So it's about 1.2 in inches. When we do our injection on a 5.5 inch PVR, we know what we're attacking, what we need to attack it with, and how we're going to attack it to obtain that goal. Mm-hmm. So your foundation will actually be able to withstand a 5.5 inch PVR, but your house will not. So they're going to pour 5.5 inches of concrete on top of it. That's all good and well. It's going to start to move. It's going to move together. You're going to see some cracks in it. But when that starts to move and all your 2x4s are bolted together, that's where you're going to start getting your cracks because those walls are not designed to move. They're designed to stay exactly where you set them. So when we get it down to less than 1%, that's what we're looking for. We're looking for you to no longer have any movement.
Okay, so less than 1%, 1% over 10 feet.
Yes, sir.
10 feet is 120 inches.
Yes, sir.
1% of that would be 1.2 inches.
Yes, sir.
So you're essentially reducing the PVR down to about 1.2. Mm-hmm. That sounds like a very good thing to do.
Yeah.
So that it stabilizes soil. Now we've done podcasts on soils here in Texas. I had an engineer that I interviewed about different types of soil. We've got some pretty nasty soil in Texas, don't we?
Yes, sir.
And what causes it to be nasty? I mean, why does it move? I mean, I know there's different types of soil out there, but what is it in the soil that causes it to have so much movement?
Clay, plasticity, the amount of water that it's allowed to take on and shed back out. That's why your house only moves in 2 seasons of the year, when it's super wet or when it's super dry. You being from Texas and everything that's around here, like Frisco, Plano, a lot of that used to have the Trinity River that ran through it. They rerouted that river, filled all of that in, and it is just trash, river bottom, dirt.
Full of silt.
Yes, sir.
Yeah, that built up over thousands of years.
Yep, that is allowed to do whatever it wants to do under there.
Yeah, not a good place to be put in a building.
Not without some EarthLok.
Not without some conditioning. Yeah,
yes,
some
sir.
Soil conditioning. Okay, so we know what soil conditioning is. Now we're changing the characteristics of the soil so that it doesn't move as much. Mm-hmm. So now we have a stable place to build a building on. Okay, so that answers my second question. My second question was, why does soil need to be conditioned? I think we just covered that, because if you don't condition it, you're subject to movement that could damage your building.
Yes, sir.
And that could cost thousands of dollars in repairs, or somebody has to. I read this statistic a few weeks ago. Texas is number one in the nation in foundation repairs and number one in the nation in foundation failures as well. And somebody said to me, well, that's because Texas is the second most populated state in the nation. Of course, it's going to be number one. Well, actually, it's number one per capita. So it's number one in percentage terms. So
Right.
we've got a lot of foundations that need a lot of help in the state of Texas.
Yes, sir.
And hopefully when people learn more about soil conditioning, we can build foundations on soil that's a little bit more stable and not have as many issues with foundations.
Right.
So that would be a good thing. So what are the options available to condition the soil? I know that you and I are talking about what you do at EarthLok, but what options do people have for conditioning the soil? What can be done? You know, I'm a builder. Let's say that I get that geotechnical report and it says that my PVR is 5.5. What are my options as a builder? What can I do? I know chemical injection is probably not the only thing available.
Right, and it's not. They're probably going to give you 4 to 5 options. One being piers, drilling piers into the ground. 2 being remove and replace. They're going to elect an amount of dirt that they think is sustainable for you to build a house on. Anything above that, they want you to remove it and replace it with select fill.
Yeah. Now, when you say they, hate to interrupt you, but when you say that, you're talking about the geotech engineer?
Yes, sir.
Okay. And he's the guy that drills the hole in the ground, analyzes the soil, and issues this report that says what needs to be done.
Yep.
Right? Okay. So I could put piers in, but as a builder, I know that piers are primarily, or their primary function is to keep a building from settling.
Right.
But it doesn't do anything for upheaval,
Right.
for the swell.
Right.
So as a builder, I don't look at piers as the end-all solution. You know, I look at piers as a specific solution, like when there's uncompacted fill, put piers in because that house might settle over time. But what you're telling me about the PVR is, depending on the time of the year, I could be pouring a foundation on soil that is very wet and it's already pre-swelled, if you will, or I could be pouring a foundation on soil that's really dry. And
Right.
then in the rainy season, it's going to swell, right? And
Yes, sir.
that foundation is going to go up. So piers wouldn't help in that regard, would they?
No, they would not. You know, and I say this a lot. Piers are great. Piers work perfect if you can elevate your slab and set those piers into some kind of rock. If you can drill those piers into rock and elevate your slab on top of them 18 inches off of the ground, you'll never have a problem with it.
Basically like a pier and beam foundation.
Yes, sir.
Yeah.
Well, then again, you know, there is a lot of pier and beams out there that do not touch rock, and they move.
They move, yeah.
Crazy.
Because piers themselves will move.
Yes, sir.
Yeah.
There's not enough ground friction for a pier to stay where it is. You know, you dig one down in the ground 15 foot and bell it at the bottom. There's enough movement down there that if it wants to push that pier up with the ground, it's coming too.
There's still going to be some movement.
Yes, sir.
Yeah. So so you talked about piers. What else can we do to condition the soil?
You can moisture condition. You can dig your foundation out down to an elected depth that the geotech specifies to. Put it back in layers. They're going to put it back in 6 inches at a time. Wet it down. Get a compaction on it. Put 6 more inches. So, I mean, if they dig out 8 foot, you know, they're putting it back in 6 inches at a time, wetting it down, getting a compaction report on each one. It's going to take a while.
Yeah. You're talking about a couple of weeks worth of work and
Oh, yeah.
a lot of money.
Yes, sir.
Yeah.
There's also water injection. Water injection, you can come in, pre-swell the clay, pump it full of water where it can no longer take on any more water. Therefore, when you build on top of it, you know, the clay is not allowed to take on any more water, so theoretically it's never going to move again. And then there's chemical injection, and that's what we do.
Yeah. I have a little bit of an issue with the water injection. Let me tell you what it is. You can tell me if I'm on the right track with this. I realize that when clay comes in contact with water, it expands. So when you inject water in the ground and you pre-swell it, you've swollen the soil where the foundation is going to be. But then I've also read that moisture moves from wet to dry. So around that injected area is dry soil. Isn't that moisture that we just conditioned the soil with, isn't it going to move or percolate over into the dry area, and then that soil under that foundation can still shrink as that moisture leaves the soil?
Yes, sir. So everything in the ground is looking for water. It's looking for moisture. Every
Right.
tree, every bush, every
Right.
blade of grass, everything. It's looking for that water.
Yeah.
So to think that you could pump 70, 80,000 gallons of water underneath a house and it stay there forever, you know, Texas, we have 105-day summers. That water's leaving.
Yeah.
You know, if your neighbor didn't do the same thing as you, and his foundation's dry, just like you said,
Yeah.
I mean, water is positively charged, clay is negatively charged. They attract each other big time.
That makes
And
sense.
It's going to pull that water out of
Yeah.
there.
So in my mind, I'm thinking, if I wanted to get crazy and just spend a whole bunch of money, I could water inject the soil with, I think you said 70 or 80,000 gallons of water. Is that realistic? Does it take that much water?
Yeah, I mean, depending on the house, yes, sir. You build a 6,500 square foot, and that's with your overbuild and everything.
Right.
You do 6,500 square foot, you're looking 75,000 gallons.
Okay. Bunch of water, bunch of time, bunch of expense, pre-swell it. Then I could drill some piers in the ground, hopefully all the way to rock, set the house on the piers, and then I'm golden, because now that moisture, as it leaves, that soil is going to shrink a little bit, and the piers are going to hold the house up.
Right.
But now I'm probably spending $30,000 on,
Correct.
getting it ready. And if I'm building a, moderately priced house, it's probably cost prohibitive to do that.
Right. That's
Yeah.
without the slab on top of it.
That's without the slab. That's right. That's just to get the soil ready.
Yes, sir.
Which is, I guess, why most builders don't do that, which is
Right.
why we lead the state,
Right.
we lead the nation in foundation failures.
Yes,
Yeah,
sir.
So not doing that.
So Texas is bad about a lot of geotechs are saying that 4.5 inches on a PVR is perfectly fine for a home builder to build on top of it. A developer comes in, geotech comes in, tells the developer, hey, you've got a 4.5 inch PVR over this whole thing. Doesn't matter if they're putting 1,000 houses or 25. Developer sees 4.5, cool, he starts selling the lots. Up to the home builder, whether they want to remediate that lot. And when I say remediate, I mean,
Reduce that, do something to reduce that PVR.
yes, sir. That's just completely up to the builder
Yeah.
at that point.
Yeah.
Why it's 4.5 is the standard.
Well,
I
I
have
can,
no idea.
I can tell you why it's in the Post-Tension Institute. It's in the guidelines from the Post-Tension Institute. They say that you can put a post-tension slab on any ground that has a PVR of 4.5 or less, or they say you cannot put it on ground that has PVR greater than 4.5.
Right.
So that's how that kind of got baked into the equation, is it came from the Post-Tension Institute. I don't know that I'm a big fan of that, because I think 4.5 inches of movement is quite a bit.
It's a lot.
I don't know any house that could withstand that much movement and not have cracks in the sheetrock and brick
Right.
and doors and windows sticking and things of
Right.
that nature. So, okay.
I agree with that.
All right. Well, we're on the same page with that. So what's the difference between chemical injection and water injection? I know we touched on that as one. Water injection, you mentioned Piers water injection, alternatives to chemical injection. You do chemical injection at EarthLok. What would be the difference between chemical injection and water injection?
So water injection, you're pre-swelling the clay. That's your whole intention. With EarthLok, we're only using water as a conductor. We just want it to push the chemical through the ground. We will not pre-swell the clay. We're going to pre-swell the clay less than 1/4 inch. Those are the two main, examples to set us apart from water injection. Also, our chemical is going to coat clay with a hydrogen ion. That hydrogen ion is positively charged. So it's going to attach to the clay, which is negatively charged. So now when water comes into contact with that positively charged clay, it's going to tell it, hey, I'm full of water. I no longer need you. And it's going to repel that water to your neighbor's house, to the tree, to the bush out front.
To the surface.
Yes, sir. Anything that's looking for water,
Yeah.
it's going to push it away.
Yeah.
Where you're just going to lose it with water injection.
Okay, so with water injection, I'm actually injecting water into the clay. The clay is saying, hey, I'm hungry for water. Come feed me. The clay swells up. You pre-swell the whole lot, or the pad site. And with your chemical injection, you're actually modifying the properties of the clay so that it says, I don't need any water. Stay
Yes, sir.
away from me.
Yes, sir.
Very good, which leads me to my last question, which I've got for you today, which is this soil conditioning, whether it's water, chemical, whatever you're doing, is it permanent? Now, and I know that's a big word, that's a strong word, but that's what people want to know. If I spend this money to do this, am I going to still have foundation problems in 20 years?
Right.
That's what people want to know. So what can you tell me about that? Is this going to be a permanent solution?
Permanent's a strong word. Very strong word. So we used to offer a lifetime guarantee on it. We no longer offer a lifetime guarantee. We offer a 10-year warranty with it. That being is because when we were done with our injection, 11 years from now, if your foundation guy, if your sheetrock guy, if your framer, if all of those warranties run out after 10 years and something is to happen to your house, there's only one person you can look at, and that's us. So we went with 10-year with the industry. Permanent is rough for me to say. I won't be here forever, so if I inject your house in 100 years, I have no idea what it's going to do.
Right, right.
Engineers have told us once it makes its ionic exchange that it cannot change back. But for me to tell you it's permanent would be
Yeah.
that would be a stretch
Yeah.
for me.
But you'd be comfortable in saying that it's going to last longer than 10 years.
It'll last my lifetime.
Okay, good.
sir.
Just can't go as far as permanent.
Yes, sir.
I understand. Now we've covered a lot of things here. We've covered soil conditioning. Why do we need to condition the soil? We've covered water injection, chemical injection, remove and replace, moisture condition, all of that. Piers. We've talked a little bit about that. And I mentioned earlier that I could do the Cadillac solution. I could completely swell the soil, put the piers in, pour my foundation. Probably never going to have a problem. Not the least expensive, but a better alternative, a more affordable alternative would be to do the chemical injection, because I'm looking at my notes here, and I've got in my notes that water injection is a lot more expensive than chemical injection. Am I right about that?
Not necessarily.
Not necessarily. Okay.
Water's cheap. In Dallas, you're paying $3 per 1,000 gallon. So if you inject 70,000 gallons into the ground, I mean, you're a couple grand.
Yeah.
So water injection, I mean, you've got the price of the machine, you've got the price of the guy, you've got the price of the water. Where it is relatively cheap. Chemical is a little more expensive than water.
Okay.
But then again, you're paying for what you get. You can have the water that dissipates over time, or you can have the chemical that is going to lock your foundation in where it is.
Right. So I'm going to pay a little bit more for chemical than I will for water. And by the way, when we say chemical, I hate to even use that word because
Right.
people bow up, chemicals. I got to be careful about that. What are you putting in the ground, and what does it mean for the plants and the animals and the soil? Am I putting something in there that EPA is going to come along 10 years from now and say, you got a toxic job site here? What are we looking at when we say chemical?
So our chemical is 100% eco-friendly. It's a sulfuric acid-based chemical. In its diluted state, it's less acidic than a glass of orange juice if you just poured it on the ground.
Oh, that's great.
If it runs into rivers, ponds, anything like that, it's not going to kill your fish. It may turn it a little green if the chemical actually got in it. But once our chemical is injected into the ground, the water that comes back out of the ground, the chemical's already spun. It's done what it needs to do. So the water coming out is just as clean as before it went in.
Perfect.
If it gets on you, in its diluted state, it's not going to burn you. It's not going to do anything. If your dogs happen to drink out of it, it may give them a little cotton mouth. But that's about it.
That's great. Great. So no toxins in the soil, nothing to worry about in the future.
sir.
You said sulfuric acid based. If memory serves me right, I think that's what I put in my swimming pool to balance the pH in my pool, if I'm not
Yes, sir.
mistaken. I put acid in. I think that's a sulfuric acid based product as well.
Yes, sir. It's a type of sulfuric
I'm
acid.
swimming in it, so
Yeah.
it can't be harmful if I'm swimming in it.
Yes, sir.
Good deal. That's all right. Well, I appreciate that. So it's roughly, I think we talked about this earlier. It's roughly, I think you shot me a price. I don't want to hold you to it, but if somebody's got a couple thousand square foot foundation they're putting down for say a 1,900, 2,000 square foot house, and you're going to inject about 5 feet beyond the pad site, right? You're going to
Yes, sir.
condition about 5 feet. Plants can grow. It doesn't affect plants growing and
Right.
all that. What could someone expect to have to pay for a service like yours?
I mean, it all comes down to geotechs. We're looking for pocket pins. That's a pocket penetrometer. They're going to take a reading of how dense the clay is. That affects our time, our stoppage. It affects how much chemical we put in the ground, how much water we're going to put in the ground. We're looking at in situ moisture. That also affects how much water we're going to put in the ground. If
Yeah,
there's
let's not get too crazy with in situ. That means the natural state of the soil, right?
Yes, sir.
What's
The soil-
already in the ground.
Yes, sir. The water that's already in the
Got
ground.
it. Yeah. Sometimes I have to take these terms and bring them down to something people can understand.
Yes, sir.
So you're looking at the Geotech report to tell what kind of clay is in the ground, and from that you're going to determine how much chemical you need to put in the ground, how much time it's going to take you,
Right.
how much water is going to be needed as a carrier to get your chemical into the ground.
Yes, sir.
And all that's going to result in a price.
Right. Each job is specific to that job.
Okay.
There are no two jobs that we've done that look exactly the same.
Okay.
So the price is, it's hard to say without looking at a geotech.
Yeah. But are we talking like hundreds of thousands of dollars, $10,000, $100,000? I mean, what?
No, you're looking in the range of $1.50 to $1.10 probably.
Per square foot?
per square foot.
Oh, okay.
Yes, sir.
Okay. So if I had a 3,000 square foot pad site, we're looking at maybe $3,500, $4,000.
Yes, sir.
And a $500,000 home going on there, it's well worth it. So,
Yes, sir.
Yeah. That's not too expensive. That's great.
Yes, sir.
Good deal. Well, before we wrap this up, like I said, I appreciate you coming in and talking with us. You're with EarthLok, a company called EarthLok. Do you want to give us just a little bit of history on EarthLok and what you guys do?
Yeah, so we're EarthLok Soil Stabilization. We're a sulfuric acid-based company. We inject our chemical into the ground to stabilize foundations, whether that be on roads, sidewalks, houses, buildings, solar farms, whatever you have. If it has clay, we can stabilize it. We're based out of Waxahachie, Texas. We work anywhere that there is clay. We've been in all the surrounding states around us. So if you've got a problem, give us a call. We'll take a look at it and see if we can't help you out.
That's great. And we'll be sure and put your website up on the video so people know how to get a hold of you.
Yes, sir.
So fantastic. Sounds like you guys have got a great product. And I do want to thank our sponsor for today's show, which is Waffle Mat. And let me tell you a little bit about Waffle Mat. Waffle Mat is the leading foundation system for single-family, multifamily, and light commercial structures built on expansive, rocky, compressible, or liquefiable soils. Over 30 million square feet of Waffle Mat foundations have been installed across the United States since its introduction in 1993. Waffle Mat not only delivers superior performance when compared to other foundation systems, but additionally delivers significant cost savings by reducing soil prep and building cycle time. Waffle Mat's a good product. Check it out. This is Barry Hensley for The Foundation Guy. I appreciate you watching this podcast. We'll see you next time.
The views, information, and/or opinions expressed during this recording are solely those of the individuals involved and do not necessarily represent those of SmartSense Structural Systems and its assigns.